right, let's take a look at question number 3. In question 3, we're going to be learning how to apply the chain rule in finding the derivative. Okay, all right, so let's go ahead and write down what the formula is for the chain rule. Okay, so if you have how do you know when you're using a chain rule? When you're looking for the derivative of a composite function, a function inside a function, okay? So let's say you want to find the derivative of f of g of x. So you're going to find the derivative of the outer evaluated at the inner times the derivative of the inner. DOED, derivative of the outer evaluated at the inner times the derivative of the inner. Okay, so just DOED this real quick. All right, one common mistake that students make that you want to watch out for is this. They do f prime of g prime of x. They simultaneously differentiate the outer and inner and compose. That is incorrect. Okay, what if you have three functions composed with each other? What if you have f composed with g composed with h of x? This is the same thing, same procedure. You do the derivative of the outermost evaluated at the composition of the two inner functions, and then you do times the derivative of the middle function evaluated at the innermost function times the derivative of the innermost function. Okay, this is known as the two chains formula. You're doing chain rule twice. Okay, so let's go ahead and differentiate this function right here. So we have the derivative of 3 times tan x squared raised to the third power. Okay, so one thing you want to know is that if you have a constant multiple of your derivative of what you're differentiating, you can always factor that out, just like you do with integrals, right? So pull out the 3, so we have 3 times the derivative of tan x squared raised to the third power. Something to note is another way to write this, you can also write this as 3 tan cubed x squared. These are exactly the same thing. Okay, so two different notations for writing the power of trig functions. Okay, so what we're going to do now, we're going to go ahead and apply our chain rule here. As you can see, this is going to be a double chains problem. Why is that? Well, it's because the inner function g is also a composition of your tan and your quadratic. Okay, so we're going to break it down so that nobody gets confused here. So let's start by breaking it down. The outer function, let's call that f. So f of x is your outer function. Okay, some textbooks refer to it as u, f of u. Okay, so it's like u to the third. And then the inner function is your composite function g of h. I'm just, for the sake of simplicity, let's just call it g for now. Okay, so g of x is tan x squared. Okay, so you differentiate both. So the derivative of the outer function is 3x squared. And then the derivative of the inner function is another chain rule. Let's save that for later. Okay, I'm just going to write it as something to be differentiated later on. We'll do it one at a time so we don't get confused. I know some of you are superstars. You can do this with your eyes closed, but I just want to make sure that everybody understands exactly what's going on. Okay, now let's see what we have. Applying the chain rule, this derivative in its intermediate form is going to be, don't forget the 3 times the derivative of the outer evaluated at the inner. So we're going to take the inner function and plug it into the outer function. Nope. Plug it into the derivative of the outer function, that's the DOE, and then we'll multiply that by the derivative of the inner function, which is another chain rule. Okay, so we have 3 times, we have another 3 here, so it's easy to mess that up. So we have a 3 here, so don't forget there was a 3 that we brought down, and then we have this 3x squared. So instead of x squared, we're going to put in the inner function, which is tan quantity tan x squared, and then that's raised to the second power. Alrighty, and then that will be multiplied by the derivative of the inner function. Bam. Okay, so now what we're going to do is we're going to apply the chain rule again in finding the derivative of the inner function, in finding the derivative of g of h of x. Okay, our formula here clearly shows us what it is. It's g prime of h of x times h prime of x. That's what it's going to be. Okay, so let's go ahead and find the derivative of the inner. Let's see what we're trying to do here. Want to find tan x squared prime. So let's break it up again. Our outer function is f. Well, let's color code it. So our outer function is f, is a trig function. Okay, so that's tan x. And then our inner function is g, which is x squared. Okay, so what we're going to do is exactly what we did here. Okay, differentiate both functions, the outer and the inner. So the derivative of the outer function is secant square x. Secant square x, or you can say secant x squared. Let's use secant x squared or secant square x, the same thing. And then the derivative of the inner function is 2x. The reason why I'm using this notation is because I'm looking at the options here and it's using secant x squared quantity square. So let's use that format. All right, so what's the derivative? We're gonna do this derivative of the outer secant square x or secant x squared evaluated at the inner. So we're going to take the inner function g and plug it into the outer function that's equivalent to g prime of h of x. Okay. All right, and then we're going to multiply that by the derivative of the inner, which is h prime of x. So the derivative of tan x squared is going to be secant. So instead of having our x, so let me show you something real quick just to make sure you see exactly what's going on. This inner function right here is going into just the x. It's going right into the x spot. Don't get it confused, okay? It's going right into the x spot. So it's going to become secant. Instead of x squared, we're going to replace it. Instead of x, we'll replace the x with x squared. But this entire thing is being squared. So it's like secant x squared times the derivative of the inner, which is 2x. Okay? All right, so to bring everything together, what we're going to do is as follows. We're going to take this answer we just got, and we're going to plug it in right here for the derivative of tan x squared prime. Okay, I mean the derivative of tan x squared. All right, so that's why I broke it down so it doesn't get too messy. All right, so this becomes 3 times 3, which is 9. 9 times tan x squared. Then the derivative of this is secant x squared quantity square times 2x. Okay, so we can combine this 2x and the 9 together. If we do that, we're going to have the final answer 18x tan x squared times the quantity secant x squared. Ladies and gentlemen, that's the final answer for question number 3. Okay, so let's see which one is the answer. Answer to number 3 is option letter C. This presentation. If you found the contents of this tutorial helpful in your preparation for your exams or calculus in general, do give us a like. Your positive feedback is very, very helpful to us. Do not forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions or comments, just post it in the comment section below. If you'd like to gain access to our epic formula sheet and other valuable resources to help you do well on the AP exam, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.